Today we will be discussing topic 13, properties of tangents. Don't forget that a tangent is a line that crosses the circle in exactly one point. It intersects the circle in one point. So one of the first properties we're going to learn is that the radius that also intersects that point of tangency, is what we call it, forms a 90-degree angle. And the really cool thing about that is we get these right triangles that you'll see in these two examples. So with right triangles, if we want to prove that something is tangent, we're determining whether it's tangent, we're going to use the Pythagorean theorem. So here I'm going to use c squared equals a squared plus b squared to determine if this is a right triangle, because if it is, then AB would have to be tangent. So the biggest number here is 20, so that would have to be my hypotenuse. 20 squared equals, maybe, we don't know, we're going to find out, that's why I'm going to put a little question mark there, 12 squared plus 16 squared. Now 20 squared is 400. When I put 12 squared plus 16 squared into my calculator, I get 400. Because 400 and 400 are the same, then I know that yes, AB is tangent. So really, we've already done this in Unit 7. We're just determining whether or not I have a right triangle. Now number 2 is a little bit different. In order to do this, I need all 3 of the sides of the triangle. I don't have this piece, or at least I don't think I do. What I do know is that if I look at this segment, we call that a radius. And any line segment that goes from the center of a circle to a point on the circle is also a radius. So this is also the radii of a circle, so it's also equal to 9. So the entire segment is 17 units long. Now, once again, I'm going to use c squared equals a squared plus b squared to determine if it's a right triangle. 17 is my biggest. It's also across from the right angle. That's the other way we can tell. So that's my hypotenuse, or my c. So 17 squared equals 12 squared plus 9 squared. We're checking that out. I don't know that for sure. 17 squared is 289. 12 squared plus 9 squared in my calculator is 225. Does 289 equal 225? No, it's not a right triangle. Therefore, I know that AB, even though it looks tangent, it's not tangent. So let's go ahead and scoot this down and see what else we can do with this lovely property. It's asking me to find different segment lengths. Well, once again, I know I have a right angle here because that's my point of tangency, and a right triangle makes this across from my right triangle my c, or my hypotenuse. So I'm just going to use the Pythagorean theorem to find a missing side. So c squared is 12.5 in this case, and I'm going to, instead of the question mark, I'll put an x. Now, I could use my calculator now. I like to do things in more like in easier steps, I guess. So I'm going to actually subtract the 7.5 squared on both sides. So in my calculator, I'm going to put 12.5 squared minus 7.5 squared. And when I do that, I get 100 equals x squared. Now, in order for me to solve this, I have to take the square root. So when I take the square root, x equals 10. So this segment length happens to be 10. Now this next one is a little trickier. If you remember from example 2, any point, any segment that goes from the center of a circle to a point on the circle happens to be the radius. So this I know is 8. Well, that's not going to really help me. I don't want to have 8 plus x's and have to square them. I'm going to actually call this entire segment x, because at the end I can always just take away the 8. This would be my 90-degree angle, so this is my c. X squared equals 8 squared plus 15 squared. I plug this into my calculator and I get x squared equals 289. Then I'm going to take the square root, And when I take the square root, what do I get? X equals 17. I'm not done. I actually have 8 plus question mark equals 17. You always have to ask yourself in geometry if you're done. Sometimes you have to plug values back in, and sometimes I have to use what I found to find what it's actually asking me for. So I'm going to subtract 8 on both sides, and then my question mark equals 9. So there's one other property of tangents that we have to look at. So what happens if I have two tangents that will intersect each other on the outside of a circle? This looks very similar to ow. But what I do know is my hypotenuse is the same in both, and that's actually the reflexive property. My radii happen to be equal, and because of this is HL, if you remember right, why these two triangles are congruent, I can also determine that this length equals this length. If I look over here, and I can actually do it if I just use the ow property, if you remember that, if you want to see why. Ow for this one is RS times RS equals RT times RT, or RS squared equals RT squared. And if I want to get rid of square root or squares, I take the square root, and what am I left with? RS equals RT. So I can prove that those two things are equal. Now here, once I get a triangle, I don't have to do all that work. If I have two tangents, I can just set them equal to each other. 3x minus 2 equals 7, and I just do the algebra. I'm going to add 2 to both sides. 3x equals 9. I divide by 3, and x equals 3.